Hello, this is third video on my channel. Let's discuss today's third question from Leetcode contest 3504. You are given two strings S and T. You can create new string by selecting a substring from S which is possibly empty, and similarly a substring from T which is also possibly empty, and then concatenating them in the order. Return the length of longest palindrome that can be found this way. From the given examples, if S is equal to A and T is equal to A, we can take the two whole strings and concatenating them gives A, which is a palindrome, so answer is 2. In the second example, the string is ABC and the second one is DF. We can pick any character from S or T resulting in a single letter, so answer is 1. In the third one, S is equal to B and T is equal to A. We can select the whole string T, which is of length 4, which is maximum answer possible. Similarly, in the fourth one, we can pick ABC from the first and BA from second, giving the string ABCBA, which is a palindrome of length 5. So answer is 5. Coming to constraints, the both lengths can be up to 1000 and both consists of lowercase English letters only. So let's take an example and solve it. If we select a substring from the first one and concatenate with other substring from the second one, if the substring we are selecting from the string 1 is bigger than the selecting substring from length 2 from the string 2, it is possible that the first one can be split into two parts, which is of two parts of S1 and S2, and S1 when concatenated with the substring taken from the string 2 is a palindrome, and the second part of the first substring we are selecting, which is S2, is a palindrome. So from the example from the picture below, when we can select ABA BB from the first and ABA from the second, resulting in ABA BB ABA, which is a palindrome. And here we can split the first one into two parts, which is ABA and BB, and the second one is ABA. So here, according to the before example, the first one is of bigger length than the second. So the first one can be split into two parts, and the first subpart is palindromic mirror of the second string we are selecting, and second subpart is another palindrome in the string. So similarly, the case can be the opposite, where the substring we are selecting from the first string is small and the substring we are selecting from the second is big, and the second one can be split into two parts, where the first one can be other palindrome and the second subpart is palindromic mirror of the first one. So from the below examples, we can understand that there are two cases possible. The first one is if the substring selecting from the first is bigger, the second one is a palindrome, and first and third concatenated form a palindrome. And similarly, if the substring selecting from the second one is bigger, the second one can be split into a palindrome and other string which is a palindrome of the substring we are selecting from the first one. So from the examples below, we can see that for the first example, it can be written as S1 plus X plus T1, where S1 plus T1 is palindrome and X is a palindrome. Similarly, in the second example, ABA PP ABA, S1 T1 R, S1 plus T1 is a palindrome and X is another palindrome. So the main idea boils down to we have to find the maximum length of a palindrome starting at an index I for any string, and then based on that we can get the answer. So let's come to the first string and discuss how to do this. So we are taking the two strings and inputting both, and the vector of int suffix palindrome n, this represents the maximum palindrome length from an index I, which is a suffix of that and is a palindrome in the string S. So we are looping through the string I and j, and if the substring I and j is a palindrome, then the string starting from I and ending at j is palindrome. So suffix palindrome I is equal to maximum of it, comma, the length of the palindrome, which is j minus I plus 1. So we are in the first string, we are taking two loops and checking whether the substring is a palindrome or not. And if it is a palindrome, we found a suffix palindrome from the index I. So we are updating that is equal to maximum of suffix palindrome of I, comma the length of the new palindrome found, which is j minus I plus 1. So the palindrome code is simple and it is recursive. So the bool palindrome int I comma j comma vector of dp and string x. If I greater than or equal to j, so if I greater than j, it represents an empty string, and if I is equal to j, it is a single character, and both cases are palindromes, so return true. If dp of ij is not equal to -1, that means it is pre-computed before, so return dp of ij. And if x of I is equal to x of j, which means both are equal, if both are equal, it is sufficient to check for the middle ones. So if xi is equal to xj, dp of ij is equal to is palindrome of inner substring, which is I plus 1 and j minus 1. If xi and xi are xj are not equal, so it is surely not palindrome, so dp of ij is equal to 0 and return dp of ij. So the time complexity of each palindrome is n square because we are memorizing the recursive solution, and this calculates only one state at a time, so total states are n square because of the space, because of the constraints n into n. So by this we can find the maximum palindrome, which is a suffix, and starting from index I, which is a palindrome. Or we can simplify this even as the following. Starting from the index I, we are traversing all the substrings starting from I till n, and we are taking the maximum length, which is a palindrome. So for int I is equal to 0 to n, I am traversing from j is equal to I to n, from that index to the last index, and if the resulting string is palindrome, takes the maximum length among all the palindromes starting from I. So similarly for the t, we can use dp2 and the prefix palindrome. This also similar to the first one, but prefix palindrome represents the prefix ending at I, which is a palindrome in t. Similarly, we can use two loops and get the prefix palindrome in the t. Now after these both, we can use another dp table to find the final answer. Here the dp3 of ij indicates that the maximum answer possible when the first substring is ending at I in s and second substring is starting from j in the second string. For example, in the first example in the picture charts below, dp of ij, where I is 3 and j is also 3, dp of ij indicates that the maximum answer possible when the first substring ends at third index and the second substring starts at third index in the second string. So we can do this in other dp because as per the dp table, dp3 of ij indicates the maximum length when the first substring is ending at I and second substring is starting from j in the second one. So if si is equal to tj, so we can use the recursion dp3 of I minus 1 and j plus 1 because we found these both as equal. dp si is equal to tj, so it is enough to check for the next ones till where these both can form palindrome. So in the first example, when index I is 3 and j is also 3, dp3 of 3 comma 3 is equal to, we found a and a which are equal, so this is equal to maximum of dp3 ij comma 2 plus dp3 of I minus 1 j plus 1. So this goes up to where these both are palindromes and are equal. So after this, the case where those both are not equal. So for example, initially I is equal to 3, j is equal to 3. So these both are equal, and now it comes to I is equal to 2, j equal to 2, j is equal to 4. So these both are equal to b. So we can increment again, and now the I is 1 and j is 5, which are a both again. So we can increment j and decrement I below. And now I is equal to 0 and j is equal to 6. S of 0 is equal to c and t of 6 is equal to s, which are not equal, so we can break. So from this we got the maximum length, which when concatenated can give a palindrome when starting at j in the second one and ending at I in the first one. So after getting these both, the x part is remaining where it is a self palindrome in the first or second. So if the x is from the first, it is a suffix palindrome of I plus 1, and if it is in the second one, it is equal to the prefix palindrome of j minus 1. So coming to the code, taking other dp vector of n plus 1 into n plus 1, and as dp3 of ij is based on dp3 of I minus 1 j plus 1, we can start I from 0 and j from m minus 1. So coming for the loops, starting the loop from I is equal to 0 and j is equal to m minus 1. So if these both are equal, as these both are equal, based on before explanation, we got a length of 2, which is I and j, which is s of I t of j, and we are checking the next cases when it can be concatenated. So dp3 of ij is equal to maximum of dp3 of ij comma 2 plus dp3 of I minus 1 j plus 1. The 2 here is s of I t of j. These two letters are included in the subsequence now. So it is 2, and we are checking whether there is a possibility of extending the string before I and after j in the first and second strings. So it is dp3 is equal to maximum of dp3 comma 2 plus dp3 of I minus 1 j plus 1. And this is just the boundary case. If I is greater than or equal to 1 and j plus 1 is less than m, only then we can access dp3, and else we are out of the boundaries. For example, I is equal to j, I is equal to 0, or j is equal to m minus 1. So we cannot increment further or decrement further. So the answer is 2 itself. And now again, after we got the case s1 and t1 concatenated both can give a palindrome, and now the other case is left where it is a self palindrome in the first or second one. So if it is self palindrome in the first one, if I plus 1 is less than n, so the x length is equal to suffix palindrome of I plus 1. So the string we thought from the from the before one is substring ending at I. So we can consider the maximum palindrome length from I plus 1, where we can add and we can get a palindrome. So similarly, the substring we selected before is started from j. So we can select any palindrome length before j minus 1. When added, increments the length. So if I plus 1 is less than n, x is equal to suffix palindrome of I plus 1. If j is greater than or equal to 1, x is equal to maximum of x comma prefix palindrome of j minus 1. So the answer is equal to maximum of answer plus x plus dp3 of ij. X is equal to extra palindrome length, and dp3 of ij is equal to the maximum length when the substring selected from the first ends at I and the second substring started from index j. And the other edge case is, for example, in this third example, s is equal to b and t is equal to a. So we cannot select characters from both because we cannot get a palindrome. So we can take any substring length from s or any substring length from t, and that is also a possible answer because it is given that we can select any possibly empty substrings. So we are just traversing the suffix palindrome, and we are checking whether there is any big palindrome in the first one itself without taking the second one. And similarly, we are traversing in the second one and checking whether there is any big palindrome in the second string than concatenated one found above. So after this, we can just return the answer. If you have any doubts, post in the comments and drop a like. Subscribe more for next updates. Thank you.